Okay, now we know Faraday's constant and kind of the how to find moles of electrons. We can actually put those together and do some half cell calculations. Okay, so these are the following, or follow these steps in order to do these calculations. Okay, you can skip, like, depending on, like, some of them, your finite amount of moles, things like that. So if you're doing unit analysis, like, you can put all of these steps kind of in one. But make sure, just like any other stoic, we always start balance the reaction. So write the balanced equation for the half cell reaction of the substance that's produced or consumed, whatever it's asking for. List the measurements and conversion factors, okay, for the given required entity. So nothing changes other than now we're writing it for the half cell instead of a total equation. So you're going to have the number of electrons are going to be part of that. Make sure when you're listing, like, your given required entities, you're going to have entities under electrons. Always under electrons, put Faraday's constant because you'll need to use it. Okay, then convert the given measurements to the amount in moles by using the appropriate conversion factor. So find, and that's again, same thing, find moles of your given, okay, times it by the mole ratio. Okay, so uh, times it by the mole ratio, desired over given, or desired or given or required over given, whichever way you do it. Okay, and then convert the calculated amount to the final quantity by using the appropriate conversion factor. Okay, so kind of going back. So your conversion factor options are like, you'll have molar mass if you're given a mass, you'll have concentration if you're given a volume, and Faraday's constant if you're given moles of electrons. Okay, and so, okay, what mass of copper deposited at the cathode of a copper electrorefining cell? Okay, so basically, our half reaction, we're going to have copper 2 plus 2 electrons is going to produce copper solid. Okay, because it's at the cathode, we know that, like, copper has to be our oxidizing agent, so that's why we're writing as copper 2 Okay, now we look at what we're given. So we're given the amount of amps. So I goes under the electrons. Okay, so anything with charge, okay, 12.0. And again, we're going to put coulombs per second instead of amps, so they cancel out. Okay, our time, 40 minutes. We want to convert that to seconds. Okay, and so 40 times 60. Okay, I'm expecting, like, at this level, you don't have to write it all out. Just 2.4 times 10 to the 3 seconds. And then Faraday's constant always goes under the electrons, 9.65 times 10 to the 4 coulombs per mole of electron. Okay, we want to find the mass of copper. So this is what we want to find. So this is our desired, this is our given. Okay, and then again, whenever we see mass, we want to write down molar mass. So molar mass for copper, 63.55 grams per mole. Okay. For this, again, you can use unit analysis, do it all at once. Right now, I'm going to show you 2 steps, okay, but then I'll show you kind of how to use unit analysis for this also. Okay, so if we're doing it in 2 steps, again, we want to find moles of given. Okay, so moles of electron is what we're looking for. The formula, IT over F. Okay, so we can find moles of electron, 12.0 coulombs per second. Okay, times our time, 2.4 0 times 10 to the 3 seconds divided by our Faraday's constant. Okay, and we get 0.298 moles. Okay, now we're going to times that by our mole ratio, desired over given, so it's going to be 1 over 2. And we get 0.149 moles of copper. And then to find the mass of copper, equals molar mass times moles. is so 0.149 moles times 63.55 grams per mole. And so our mass, 9.48 grams. Sorry. Okay, if you're doing unit analysis, okay, you could just usually want to start with, like, it doesn't really matter, but if you start with minutes, and you don't have to do you can do the conversion as part of your unit analysis as you go, okay, and just kind of go through it all. So I'll show you an example here on the next page on how to do unit analysis when you're doing these problems. Okay, so for the rest of these problems, I'll do unit analysis and show you how to do that. Okay, so silver is deposited on objects in silver electroplating cells. So if we have 0.175 grams of silver is to be deposited from a silver cyanide solution, okay, in a time of 10 minutes, predict the current required. Okay, so again, we want to, like, silver, okay, we want to make silver solid. So we're going to get that from silver 1 plus 1 electron will produce silver solid. Okay, we're given the mass of silver, 0.7 or 175 grams. Okay, and then again, as soon as we have mass, we want to write down molar mass, 107.87 grams per mole. So this is what we're given. Okay, we want to find, they are required now is going to be, we want to find the current, predict the current required. So I, that's our unknown. Okay, we want to write down our time goes under here. Okay, so it's 10 minutes. We're going to do the conversion as part of our unit analysis. And then we'll have Faraday's constant, 9.65 times 10 to the power of 4 coulombs over moles of electrons. Okay, so we start finding moles of given. And so we'd start with what we're given, 0.175 grams times 1 mole over 107.87 grams. Okay, we've done lots of those before. Okay, this will give us moles of given. Now we want to times it by the mole ratio. It's a 1-to-1 ratio. Make sure we show that. Okay, times 1 over 1. Okay, now we need to get it in, we want to end up in coulombs over seconds. Okay, so we know seconds is going to be on the bottom. And so really, like right now we have moles of electrons if we put an equal sign here. Okay, and so let's get rid of the moles of electrons. So moles of electrons in Faraday's constant's on the bottom, so we're going to flip it. So we have moles of electron over 9.65 times 10 to the 4 coulombs. Or sorry, no, this is moles of electrons. This is moles of silver. Sorry, I got that backwards. Okay, and the kind of the way I figured out that I did that wrong is because I know I have to have coulombs on top because I have to have coulombs over seconds. So 9.65 over moles of electrons. So now the moles of electrons cancel, moles of silver cancel, grams cancel. Okay, now I need it over seconds. Okay, so, but like right now for my time, I have minutes, so I'm going to go 1 over 10 minutes. Okay, I'd have coulombs over minutes. I want coulombs over seconds. So for every 1 minute, I have 60 seconds. Okay, now everything's canceled off and I have coulombs over seconds. This will give me my answer, 0.261 coulombs per second, or 0.261 amps or ampere. All right, next question. A current of 55 kiloamps passes through a chloralkali cell. What mass of chlorine is formed during or for 8 hours. Okay, so again, with the chloralkali process, like we're forming chlorine from chloride. So we have chloride, and that's forming chlorine and 2 electrons. Okay, we have to balance out the chlorine, okay, and balance out the charge. That's why we have the 2 electrons over here. Okay, so that's our half reaction. Okay, it's asking what mass of chlorine. So this is the mass we're looking for. Okay, molar mass, because there's 2, we have to times it by 2. So we got 70.90 grams per mole. Okay, under the electrons, we want to put our I, 55 kiloamps. Again, we'll convert that during our unit analysis. Okay, for time, 8 hours. Again, convert during unit analysis. And then Faraday's constant, 9.65 times 10 to the 4 coulombs per mole electron. Okay, so this is what we're given. This is what we're desired to find, or you desire to find. Okay, so we'll start with what we're given. Start with, let's say, I. So we got 55 kiloamps, or I guess kilocoulombs over seconds. And we're going to times that by 1,000 coulombs and a kilocoulomb. And so now we got that. So we have coulombs over seconds. Okay, now we'll put in our time, 8 hours. Okay, we want to convert that to seconds. So we'll times that by 3,600 seconds in 1 hour. So hours cancel, seconds cancel. So now we have coulombs that we need to get rid of. Okay, so to get rid of coulombs, we're going to use our Faraday's constant. So this is where we'll flip it over. So because we want moles of electrons, so we're going to divide it by 9.65 times 10 to the 4 coulombs. So the coulombs cancel. So again, if I put an equal sign right here, I would have moles of electrons. Okay, so now once I'm doing that, I want to have moles of chlorine. So I'm going to times by mole ratio, desired over given. So I have 1 mole of chlorine for every 2 moles of electrons. Okay, so again, equal sign here will give me moles of chlorine. Now I'm going to times that by 70.90 grams for every 1 mole of chlorine. So our molar mass, this cancels. So now I'm given, like, my only thing I'm left with is grams. And once I calculate it all out, okay, I get 5.8 times 10 to 5 grams. So for this one too, like I could have left the kilo there. If I didn't do this, then I just get I get a little bit smaller number. I get 5.8 times 10 to the 2 kilograms. Okay, so like if I didn't want to convert that, that would have been just fine. All right, hopefully these help. Let me know if you have any questions.